Welcome to Excelopithecus, bringing Excel techniques into the Neolithic. The funky shape you see before you is a Mandelbrot set, and today I'm going to show you how to make one in Excel with just one formula. You heard right. No VBA macros, no Python, no JavaScript, just good clean Excel. Now, Mandelbrots have been made in the past in Excel, and there have been many valiant attempts, which you can find in the video description. But this time, you're going to learn how to make a Mandelbrot the modern way, and better, you'll learn to scale it up as a custom function so you can keep generating new variations on it, magnify it, explore the strange reaches of Mandelbrot space, and even use exponentiation to make it mutate into a crab monster, the likes of which mankind has not seen since the invention of the electron microscope. Stay tuned for Excelopithecus. It's time for a quick run-through on how to make a Mandelbrot set. Each Mandelbrot set starts with a grid of coordinates. These are going to generate your pixel values that you're going to use with conditional formatting. In this case, I've generated one using the sequence function, and the vertical axis starts at minus 1.12 and ends at 1.12. The horizontal axis starts at minus 2 and ends at 0.47. To be able to use the grid in a Mandelbrot set, you have to convert it into complex numbers. Fortunately, Excel has a function that does that, called, predictably, complex. Now, you don't need to be daunted by complex numbers, even if you've never learnt them at school. Excel has a handy suite of arithmetic functions that can read and manipulate them. Now, let's take a single pair of coordinates from that grid, minus 0.9 and minus 0.62i. We're going to pretend this pair of coordinates is called C, and keep applying the same arithmetic step on it over and over and over again. You can see the functions Excel uses here. Basically, we are waiting until the number explodes. If it gets too big for Excel, then we record how many steps it lasts before it blows up. So here, applying the same transformation again and again and again and again, we see that this particular pair has reached 13 steps without getting nuked. Rinse and repeat, and you have all the coordinates for your Mandelbrot set. We are now going to use our Neanderthal ingenuity to generate a Mandelbrot set in a blank spreadsheet. You're going to want Office 365 for this because the functions we're going to use are relatively new. We'll start with generating the horizontal array. To do this, we'll use the sequence function. Sequence has 4 inputs in it. The first is how many vertical numbers you want. The second is how many horizontal numbers you want. The third is which number to start with. And the fourth is how much to go up or down with each step. So, for instance, sequence open bracket 10, close bracket, gives you 10 numbers in a vertical sequence. If we add a comma, leaving the first input blank and just having moving the 10 to the second input, we will get the numbers horizontally. We're going to start with, let's say, 100 numbers horizontally, and we want to start at minus 2. Now, sequence by itself increments by 1 each time, but we want to increment by 2.47, so it goes from minus 2 to 0.47, and divide it by 99. As a pro tip, always divide it by the number of pixels minus 1. Okay, we have our horizontal array. Now we're going to want to save and reuse this. For that, Excel has a function called let that lets you assign names to things and use them in the same formula. So let x, sequence all the stuff inside, will mean that when you use the term x later in this formula, it'll always reference that particular sequence. So this is what we've done. We can now build our vertical array. So we're going to call that y, and we're going to use sequence again, 100 in the first position because it's vertical, and let's start at minus 1.12 and 2.24 divided by 99, and we can see what it gives us. Finally, we just need to put them together in a grid of complex numbers. So for that, complex x, comma, y. And there you have it, your complex number grid. Now, we're going to shift our grid a little bit because we're going to take a look at what's going on with these coordinate pairs. Let's choose one of these, maybe this one, and put it here. And you can see that it's basically a text string. In fact, is text should return true for it, and you can't do a regular arithmetic with them in the normal Excel way. So adding 2 to it will just get an error. What you can use, however, are these im functions. Most of them, except image, do some kind of arithmetic transformation on the imaginary numbers. They can read them and they can transform them. So IMSUM 2, and this will add 2 to the real component, and you can see that. And if we want to raise it to the power of 2, we can take this, IMPOWER, and 2. And so we're going to do the Mandelbrot transformations now. So for these, you have to start with the number 0, which I'll just display here. IMPOWER 0, 2, and that will of course return 0. And IMSUM, we're going to keep adding that coordinate pair to it. So lock it down, and we'll see how many iterations it takes before it blows up. You can see that right here. So we don't actually need to keep dragging it like this because I've promised you a single cell formula. So we fortunately have an Excel function called scan. So for scan, it keeps recursively transforming the same number here and doing it for a certain number of steps, which we can set with sequence. It won't actually use the sequence values, they're just as a timer for the function. And LAMBDA is a function that allows you to set an Excel transformation. So we'll call, you have to put in the inputs first, and we'll call these Z and N. Z will be this one, and we'll keep this as it is for now. So you can now see the scan function has repeated the same step over and over again. Now to find out and count how many steps it takes before getting nuked, we can simply use isError, and this will show false and true. Now a handy little trick to count them all up is false counts as 0 in Excel and true counts as 1. So 1 minus isError will return 1s for each step that isn't an error. We can now just sum them. So we can see that this coordinate pair has gone through 11 steps without blowing up. How do we do this with our main grid? First thing we want to do is name complex cgrid so we can reuse it. Now we can't run scan on its own for each of those coordinate pairs, but we fortunately have a function called map. And map allows us to break it down and do the same transformation for each of those coordinates. Each of those coordinates, apply all of those scan iterations to it and spit out the result. cgrid is the first input for map. Second input that map takes is the LAMBDA function, which is Excel's way of programming a function. So for LAMBDA, we will just call the input C, and this C stands for each individual one of these, one by one. Now we can have sum, 1 minus is error, scan, 0, sequence. We'll set iterations to 30, which is fine unless you're doing really high resolution Mandelbrot sets, then you'll want higher amounts of iteration. And lambda, zn, and IMSUM, IMPOWER, z2, and c. We now have all of our numbers for the Mandelbrot set, and we can get rid of these. So to be able to generate them as pixels, let's go to Format, adjust column width to 1, and adjust row height to 2. Maybe we need a slightly lower column width than that, so let's make it column width 0.2. We now have a nice compact little grid there. And for conditional formatting, we simply need to apply color scales, and voila, we have our Mandelbrot. I've moved our formula to another sheet, and we're now going to take it to the next level. We're going to build a dynamic custom function that we can use to generate a Mandelbrot instantly. So, to start with, let's create a lambda function here around our existing formula. We're going to give it the following inputs. Xcentre, which will show the center point of the x-axis, ycentre, the center point for the y-axis, xrange, yrange, pixel, iteration, and an optional value in brackets, z_power. This will allow us to create crab-like monstrosities by raising the coordinate number to powers higher than 2. Now we're going to make a few modifications to our let function. To start with, we're going to find the start value of x, which is simply xcentre minus xrange divided by 2. We want to start it halfway. Then we find the ystart, which we do the same thing, and see ycentre minus yrange divided by 2. Then we're going to set the number for the power, and it's wise in a let function to do this early to avoid lots of recalculation. So we'll just call this PWR, which is if ISOMITTED z_power, then 2, otherwise z_power. So we now have the power value. We can now just go about changing out these numbers, and pixels instead of 100, and xrange divided by pixels minus 1. And y will do the same for y. And xstart, ystart. Now, we'll go down to the actual function and see what else we have to change. Iterations. And PWR. And I believe that is it. We simply need to add an extra bracket to close our lambda function, and then we can test it in the spreadsheet before we embed it. So it currently has 6 mandatory inputs and 1 optional input. So let's make xstart around minus 1.2 and ystart at 0. Actually, yep. And xrange should be around 2.47, yrange 2.24, pixels 100, and iteration 30. So we now have I've probably gone a little bit off center here, but we more or less have our Mandelbrot set here. So let's embed this into the workbook and create new Mandelbrot set. We can go to Formulas and Name Manager for the embedding, paste the lambda into here, and call it Mandel. Okay. I now have our Mandel function set up on a new sheet with coordinate inputs and everything else as cell references here. I've set the X and Y centers to a special point I like to call the Tentacle Zone. You'll find out why in a moment. But for now, let's look at this Z power. This is how we're going to make our crab-like monstrosities as promised. Now, an easy way to do this is with a spin button. You have to do this from the developer ribbon in case you don't have it already. Just go to Customize Ribbon and make sure that Developer is ticked. So we're going to add a spin button here, and you will notice that this cell is taking this value and dividing it by 1,000. That's because the spin button can't add fractions. So we have to start with 1,000 and increment it by 50. We'll put it right here and go to Format Control, select this cell, and incremental change of 50, and minimum value 2,000. Let's do that. Now, watch what happens when I keep pressing this button. As you can see, our Mandelbrot seems to be undergoing some sort of monstrous mitosis and splitting into weird new shapes and growing new limbs. You can see it's now becoming sort of crab-like, and yeah, I'm going to roll with that. So the other thing we're going to do now is let's reset this back to the original and zoom in on Tentacle Valley. So I've got these, the ranges, and just for convenience I've built a drop-down menu that goes down by powers of 2. So let's set xrange to 0.125, yrange to same. The Mandelbrot that's being generated is now heading into the valley. We are getting closer and closer to our target, the tentacles. So, can you see them? And let's go to the highest magnification we can and take a closer look. Mandelbrots, being fractals, keep getting new details as you zoom into them. They never stop. So, you can now see these sort of tsunami limb-like things. Now, if you want to get some more detail to it, you can simply increase the iterations. Let's do it to 100. And voila! There's been more space whittled down from the Mandelbrot set, and we can now see this odd sort of tentacled thing emerging. Well, and that is one of the beautiful things you can find by exploring the spaces of the Mandelbrot set with Excel. Well, that's it for this installment. If you want to steal my Lambda and make your own Mandelbrot sets, check out my video description. Merry Christmas!